Welcome to another GCBASIC video. This video is about what's called reliability testing, and I thought I'd share what goes on before a release to ensure that the code is reliable. Let's get started. So GCBASIC is a compiler, it's open source for PIC AVR and LGTs. It supports nearly over 1,400 microcontrollers, and it's cross-platform. And that means that we have to sort of understand if it supports the PIC, what's got broken when we made a change with the AVRs, LGTs, and all these microcontrollers. So how do we go about that? Well, I'll come back to that video in a minute, because this is the principle of operation. There are some things that we know. Okay. Well, I'll look at my pen. We know that if we run the compiler, and we take some source file and we put it through a preprocessor, it will suck in the DAT file. It will suck in the DAT file, some chip constraints. Let me have a look here into here, and the libraries. They'll all get sucked in, and then it will do some pre-processing. And if the compiler crashed during this process, we should be able to detect it. And that's the principle of operation. We know that when it assembles, it's going to create an assembly language file. If it gets through the assembler, we know it got there. Okay. Now, what's important is that if it crashed halfway through, we would also know because it didn't create a .asm file. We know that if it gets through the assembler but there is a bug, it will come into the report file called error.txt, and it will list out all the errors for us. And we also know that if it comes through GCBASIC, it will produce a hex file. So we can test whether the report file, the error log file was created. We can test whether the ASM was created, and we can test whether the hex file was created. And we can test that for a lot of files because we have a lot of files to test. And it will test whether there's a mistake in the library, a DAT file, or your source code. I'll explain. Let's go back to this diagram. So reliability testing is a very simple set of batch file. It's a single Microsoft DOS batch file, and it tests 2,500 demos. All the demos are retested on a regular basis, and it's fully automated. And how it does that, it starts and it counts the number of demos, just so that you've got an idea of what you're looking at. And then it runs this command here. It says for all the demos in the demo folder, do something. And that do something says, right, the first thing it does, it says, right, it cracks open the GCB file, the source file for each source file, and says, does it say skip test? Well, you might go, oh, why does it say that? Well, because some of the demos actually have bugs in them purposely to test things. And I can't run those through the test program because they'll throw up the errors. So there is a folder called bugs, and they are fixed bugs, and they will just cause issues. So if you have a file that looks like a GCB file, but it's actually not a source file, you could actually add in #skip test somewhere in the GCB source, and it will just skip it. Well, if it finds a valid GCB file, it compiles it, and it compiles it with the command line of GCBASIC, the file name source, and it produces an output. No, that's no pause, by the way. An output called compile.asm. So I force it to output not the name of the source file like you're all normally expecting, but I force it to create an output called compile.asm because I'm going to test against that. I force it to use GCASM. I force it because your setup might say use another type of linker, assembler, like PKS or AVI ASM2, and I need it to be GCASM because of consistency. Because I don't want to be testing those. A couple of other switches that I can't remember what they do. It might be leave the comments in, and then I say use the ini file, the setup file called use.ini. Use the ini file, and don't program it. So what it's going to do, it's going to compile that source, it's going to create a compile.asm, it's not going to try to program it, but it is going to use GCASM. And that means I can now test, I can now say, well, if it comes through, does this exist? If it exists, then we know there's an error, and I update a log file. Well, in the next phase, it goes, is GCS, was compile.asm. If that does not exist, I know there is a problem, update the log file. And then I can say, did it create a hex file? If it did not. If it did, obviously it goes around to the next file, it updates the log file. So this very simple batch file, you can have a look at it if you want to. It's called test all demos, and it will just test all the demos. So why don't we have a look at that? So what I've got, I'm actually looking into the fastest computer that I've got, and it's not the actual one I'm sitting at, or my lab one, it's upstairs, and I've got it connected through a remote terminal. So let me get rid of that. I'll get rid of that. You should just reconnect into my machine upstairs. Shouldn't have done it that way, really. That's really stupid of me. Let me just reconnect. There you go. I'll reconnect to it. Just unlocking it. And there's my C drive. I'm looking in now on another machine. I'm going to click on C drive and GC Studio, GCBASIC. And in there, there's all the files, and you have exactly the same files that I have. And there is a number of batch files here called test. And if anyone's ever wondered what this is the batch file I've just been referring to. So if I open that in Notepad, here it is. It's just what I've been describing. Let me just move things around for you. It says some setup stuff. The files I'm looking for are GCASM. It does the count here. Here's the actual command that says loop through all the demos with that file specification of GCB. It says look, make sure it's got a chip. Make sure it's got chip in there. If it doesn't have hash chip in it, don't try compiling it. Obviously, that's an invalid source. I didn't know that. There's a file called invalid source. It deletes the error log, and then it comes through. Does it have skip in it? Skip test. If it doesn't, then here's the command line here that I just showed you, and then it goes through and does some testing. Does this exist? Does that exist? Increment the counter by moving it south and do it all again. So what does that look like when you're actually doing it? Well, I'll minimize that. I'm just going to click on it. So it's counted the files, and now it's running. It is running. And unfortunately, if you haven't donated, you will get a beep every time it does this, which is quite annoying. And this will take many hours on your computer. If you don't have a very fast computer, this can take many hours. This computer takes less than 1 hour to run, but it's going through every single entry. Now, it's producing a test log, and it says it started here at 10:49. That's great, because that's a true statement, because it sort of did start about then. Skip log. Has it got what's in the skip log? Where's skip log? Our skip log has just got an entry in there, an invalid sources.log. Let's have a look what's in there. And nothing in there yet, so it hasn't found anything that it's thrown out. Now, I don't actually use Notepad to do this. I come back to it hours later. So what I'm going to do is, in true videoing style, I'm going to stop the video, and I'm going to come back to this in an hour's time, and we'll see that it's actually gone through because it's running away in the background, chirping away. And let me just reassure you before I actually stop the video, in here, if I press function key F5, what it's doing, there it is, compile.asm. It existed for a few seconds. So it's going through, it's tidying up each time. Whilst I'm here, I'll just show you two other, what's the word I'm looking for? Tests. There is test all chips compiler. That will create a test GCB file for every single chip that's in the chip folder. It's very similar, I mean, but what it does, there is no source. It creates a source file for every chip, and therefore it goes through and compiles a test program for every single chip. And that's quite impressive, I would say. Let me have a look at the other tests in here. Test all chips. Test. If I actually do it by batch file, let me find all the batch files. Another set of batch files in here. Let me just type that in there. Test. These are all the logs. Oh, there's only two in here. That's right. So it's test all chips and test. What am I doing? Oh, here it is. Test all chips and test compile all demos. Let me just move the screen down so you can see that. These are the two batch files that you've got. If you run that one, if you actually run test all chips, it will update the pick info database as well at the same time, and that's why it exists. It's quite useful to keep that thing updated. Anyway, I am now going to leave this running. I'm going to search by date. Have we got anything in invalid sources yet? Oh, there we go. Look, we've actually got something coming in. So an invalid source is this file here. So there's a file in here called that, and it says it's an invalid source. What does that mean? Oh, let's have a look. We'll open that file to see what that means. Well, it's got no chip in it, look. All right, there's no chip in there, so it can't compile it. It's obviously a subset program that's actually been tested for another reason, so it's probably been included in a file. And so you can see there that as it doesn't try to compile anything without a hash chip. That's very good. Let's see what's been skipped. Nothing been skipped. We'll come back to that in a few hours' time, and we'll see where we get on. So we're about 30 minutes into the reliability testing suite. Let's have a look at what's going on. I'm dialing into my other computer here. Let's have a look. So it started at 10:49. It is now 11:33. So I'm going to look at the invalid sources. So great, we've got some invalid sources, which is all good. It is good to have invalid sources. So if you want to go and have a look at some of these, you'll figure out that these aren't actually valid sources. You couldn't compile this even if you tried. Okay. Let's have a look at this one. I'm just taking one at random. It says it's an invalid source. So I'm just going to open it up in Notepad. Here it is. Well, it's an invalid source because this doesn't have a chip statement. This includes something called Uno Mega. It must be a very old program. It says it's this date, but trust me, some of the dates, I just updated them. I went through all the demos, I think in 2021, and I just changed them all to 2021. So even really old demonstrations, because I've not seen this for years. I don't know. It says my name against it, but probably took it out from somewhere else. Anyway, so that won't compile because it doesn't have a hash chip statement in here, which is correct. Some others in here. So there's what it says in here, 84 lines. Let me just bring that across. 84 lines, yeah, 83 lines. Obviously got some wrap in there as well. So that says 137 of the files could be, what's the word I'm looking for? 137 of the files might well be, I'm so sorry. It's playing up here. There we go. Bring it across. 137 files aren't compilable, which is absolutely fine. In terms of skipped, let's have a look at skipped. Skipped log. Most of them are actually in the test solutions folder because these are files that may have been created during a change 126, 1162, sorry, and they don't generate those errors, but I don't want to actually clutter things. So they've been marked as skip, and it's just carrying on. It's been no errors as yet. Let's look at what it's doing in terms of the command line. It's just chirping away. What it's doing, it's counting down. It says, let's have a look, compiling some file. Compile gives it the time, how many lines, how many libraries, etc. And it's just as if you're doing it inside of GC code. It's exactly the same outputs. In terms of the version, it says it there somewhere, 1447. That's a very new build. I think I got it from Angel this morning when I did my own update. I use the same release level as you. I don't use any other difference. I just use the live one. Otherwise, it wouldn't be tested. As you can see, it just chirps away. Anyway, we'll come back to this in a short while. Well, it's 12:24 now, and the test log has actually completed. So if there have been errors, there would be a long list. And there often is errors because libraries have changed and I've made an error in a library. And it could be deep inside a library or it could be in the user program. But this would have listed all the errors in there. And I just don't have any at the moment. So it's quite good, isn't it, that Anthony? So let's go back into PowerPoint and just see what I was trying to say. So went through that. That's the process that existed. So you've seen it run, and there was nothing in the log.txt, which is fantastic. Let's just remove the ink. Great, we saw all that. That's very good. So reliability testing was this tests the end-to-end compilation process. Clearly marked, it misses and skips over files that are marked as skip test, and it also does not try to compile files that are not source files. We saw some of those. It tests about 2,600 files, going back to, some of them go back to the very early days of GCBASIC, and they still compile unchanged because they don't use the more advanced options. So they need to compile, they need to be reliable. Okay, there is some assumptions. There is an assumption here that says all the files in the past worked, and they did. They did work, therefore they should work tomorrow. Okay, and there is an assumption that the compiler and any library changes will cause an error and they will therefore fail compilation. There was a case many years ago when I was doing this where for some reason the batch file managed to get through a memory error inside of the compiler. It now traps those because it's actually a little bit better, but there is an assumption that it will cause the error log to be written or the and these two files will be written out, the ASM file and the hex file. There is a risk with this approach. This is what I call immunity of source programs. Testing the same things over and over again with the same program that does test a set of routes through the compiler and the toolchain that actually is tested. It's okay. It's like immune. It becomes immune. The compiler becomes immune to these tests. because it always passes. So what you need is to test on real silicon. Well, we can't do that because we can't have 1,001 different microcontrollers hooked up. It is not possible. The variety of chips, I mean, there's so many chips involved. And I need to keep pumping new demos into the pack that is testing to change the scope. And that will change things. So I've just added in all the Q24s. Q24 tests it again. Hence, that's why I ran it. So it does test the end-to-end. There are some assumptions. There is a risk. Case there are, let's move on. So if you want to see the full list of changes that have happened in 1 year, go to that URL. This year's been 200 major changes. We've added in a couple of hundred more microcontrollers. We've added in EEPROM blocks and data blocks. Floats, huge change in the floats area. I mean, just massive, okay? New chips means that we've had to change. Well, I'm sorry, I should go back. When I add more chips, it invariably requires changes to the libraries to support all these new chips. And if you followed along in the other videos, it's quite extensive, some of those changes. And we're constantly tweaking and adding the LCD stuff because we've changed the performance or the compilation time by changing the way that we optimize GLCD. But it does allow you to create more sophisticated GLCDs. And I will be writing a 7-inch driver and completing that in the new year. So this is a summary. So whilst this has its risks, it's very valid because it has a proven track record in the context now that you get GC Studio managing your environments and it doesn't break everything. It means it must be working. But you can run these tests on your own, and you can run these tests on your own files by taking that batch file and just putting it in your you can just change the batch file and say, don't do it in the demos, do it in your local folder. So you can steal this. So reliability testing is pretty cool. Fully automated, and it seems to work. Enjoy.